Welcome everyone. Today I'm going to discuss about what is an inode, what are the hard links, what are the soft links, and difference between these. So the inode number is a indexed node which actually refers to any specific file in Unix file system. So as you know that in Unix every entity is a file, means whether it's a regular file or directory is also file type, could be a device file or block file, pipe, everything is a file. And each file will have its own inode number, and that inode will have a data structure such that it will store the information of the attribute of the file, the owner name, the name of the file, size, uh, permission, the modification time, access time, change time, how many links are there for any specific file. Um, yeah, these information will be saved in a inode data structure. I will create a file f1, and now if I run ls minus I on this file f1, I will get a number. This number is a inode number of this file f1. Okay. Parallel to explaining the inode, I will also explain what is the hard link. So hard link can be created by ln command without any option, like you just run ln and then you give the file name which exists, and then you create a new link. So now let's run ls minus I, and you see that the inode number of f1 and inode number of hl are same. This is the hard link. In hard link you can have multiple hard links, but every hard link will have the same inode number. Okay, while the soft link will have a unique or another inode number, if not same as the source file inode. This is the main difference. Now if I now this is one. What I will do is now I will show you a command called stat, and I'll run this command stat on f1 and hl both, and try to understand the output. So this is the output for f1, and this is the output for hl. Then they should be exactly the same. You can see number of blocks, size is 0 right now, and the permission 640 in both. Basically, I am showing the attributes of the same file because they have the same inode number, right? Just the name are two different names. You can see the access time here, modifying time and change time. They are exactly the same right now. Now let's modify this. Let's just play with the modification time. Okay. So when I add something to a file, then it will affect the modification time, but it will also affect the change time. Why? Because if you add something, it will change the size of the file, and size is one of the attribute of the inode. So the change time is inode change time, and the modification time is the when you modify the file, and access is the when you access the file, that time. Now let's try to add something in the file f1. Okay. So now you will see that the modification time, which was this, and this was the change time. Now we'll see how it is affecting. Okay. So we run this stat command again for f1 and hl. You can see that modification time has now been updated. Also the change time has been now updated. Right? Now let's change the permission of the file hl. And if you run again the stat command, You can see the permission of both the files have been changed because they have the same inode number, but the change time is now changed also because the permission is only the attribute of the inode. Hence, only the change time will be affected when you change the permission of the file, not the modification time. I hope this is clear, right? Now let's try to update the access time. Updating the access time will also change the change time also because that has a attribute of read access. Now you can run touch command minus a option and give any file, like give the file name here f1. Okay, now run the stat command again and see the output. You can see the access time is now this, and the change time is also the same now, but the modification time still remains the previous one. So this is how you can actually check these things. And you see another good point, an important point as the link are two. It shows you how many hard links are created. Okay, I hope it is clear. Now, what is the soft link? Soft link can be created by the option S minus S. It is also referred as symbolic link. And let's create a soft link for file F1. And the soft link I will create SL. Okay, long list. This is the soft link. But and also remember that the hard link they show like a regular file, but the soft link start with a small l. Now if you run the ls minus I command again, you can see the soft link inode is different than the actual file inode, and this actual file inode is same as the hard link inode. This is one difference, right? You can update the soft link also to update the main file. So let's just add here def. Okay, now look what happens if I run cat f1. It will have abcdf, and if I also do cat hl, it will also have abcdf because softlink was the softlink for f1, but f1 and hl are hard link, so both are affected. Okay, so this is it. Now if I remove f1 actual file, this will break the hard link. So make sure the source file is not deleted or affected, otherwise the hard link will be broken. Now if you try to cat the soft link, it will be an error because it is not it is pointing to f1 which doesn't exist. So you can create another new f1 now, and now you will see that f1 is again intact. But please note that now the f1 inode is different than hl because it is a newly created file. Let me show you another example of soft link. You create a directory structure a, b, and c, and you create a file inside abc file. Let's say call it file. Okay, now let's create a soft link ln minus s my file. Sorry, first I have to give the source. So the source is abc file, and I'm creating a soft link called my file. Now you can see the my file has a soft link for this file. So this is a good way. Now I can simply let's say if I write something inside this soft link, echo hey my file. Okay, so it is essentially writing inside the main file there, hey. Okay, so this is a very easy way of handling file under deep hierarchy, and you want to control it from the top level. You can do that. By the way, soft link can also be used for the directory. Let me show you an example. If I run ln minus s a b c, and here I'll create a soft link called cdir. Okay, so you can see the cdir has been created for this directory. Okay, change directory directly to cdir, and this will go inside the c directory. It's directly like that. So you can see now I'm seeing the file. You can come back in one go by cd slash. We have come back here with the cd slash command again. Okay, so these are some practical examples of soft link and hard link, and I hope you understand this concept much better. So this is it for today, guys. I hope you liked or you learned something new today. Take care. Bye.